Okay, so this is a roundtable I'm very excited to moderate. For those of you who have been following the initiative, you'll know that we've talked a lot about applications for storage for carbon, but not so much on the utilization side, but that will change now. So I'm very excited to get to moderate this session on utilization of carbon and looking at different market products and opportunities that we can do with captured carbon. We've heard a lot on the natural sequestration side and the industrial side, but this is an avenue of utilization that can unlock some pretty cool things. So I'm very excited to be joined by an expert panel, people who know a lot more about this subject than I. So I am going to turn it over to our panelists for opening remarks. Emily?
Thank you. Hi, everyone. I'm Emily Connor. I'm the Acting Division Director for Carbon Conversion with the U.S. Department of Energy. I sit within our Office of Fossil Energy and Carbon Management, and so this is where a lot of the activities of the department with regards to carbon management are housed. So carbon conversion is one of our divisions, but we also have carbon transport and storage, which includes the pipeline work that came up in the prior session, carbon dioxide removal, hydrogen with carbon management, as well as additional work on across what we call kind of the supply chain or the value chain of carbon. So excited to be able to talk to you all here today about some of the work ongoing in conversion. And so in these slides, I just wanted to provide a bit of brief context around what specifically the U.S. Department of Energy is doing with regards to carbon conversion, also called carbon utilization, and some of the priorities that we have in the program, as well as a couple opportunities related to the space. Some of which are specifically geared toward states and local governments. So very excited, and thank you for the opportunity to be able to hear talking to you all today. So within our carbon conversion program, kind of our overarching mission goal is to research, develop, and demonstrate a number across a broad suite of technologies for carbon conversion. So we have 3 different pathways that we, as a program, typically refer to. The first is biological, so this is mainly algae, so using carbon dioxide captured from something like a point source, power plant or other flue gases to actually cultivate algae, which then can be used in the development of products. We also have a catalytic conversion pathway. This, I would say, tends to be the earliest stage of the technologies, but it's a high risk, high reward technology, and that there's a lot of opportunity for things like SAF or drop-in fuels. So there's a lot of interest there, obviously, ongoing at the moment. Our program focuses specifically on opportunities for CO2 use in that process. And then finally, mineralization. This is an inorganic pathway. This is a lot of times when we're thinking about things like CO2 into building products. This is one of the pathways that we consider. This is probably one of the more market-ready pathways, so a lot of exciting opportunities coming out of that space. Just a note on our funding, you'll see the breakout there. Obviously, I don't have any insight into the federal budget process, but we did receive funding through the bipartisan infrastructure law that has allowed us to really think strategically about what we want to fund in this space for the next several years, and in particular, really thinking about what we as the federal government need to be doing to enable a scaling of these technologies and kind of the commercial development and deployment, which is a little bit of a different change in tack, I'd say, from what FECM and some of our R&D offices have focused on in the past. So it's a good opportunity for our office to really understand what challenges these technologies face and where are federal funds most needed and helpful. Just a couple goals that I've already mentioned, so I won't go into too much detail, but another area that we really focus on is the life cycle analysis, assessment, and techno-economic assessment tools. They're particularly important for this space. They've come up in a couple of our prior sessions. But this is a big area of focus for our program because we need to ensure that not only are we coming up with low carbon alternatives, but that we can really robustly quantify where we're seeing those emissions reductions and what they are. And then finally, a couple notes on the challenges, I think, generally in this space. There's, I think, when we talk about carbon management, particularly carbon dioxide removal, in a lot of ways, carbon conversion might end up being a smaller slice of kind of that overall pie. I think when you talk about the scale of storage that we have in some of the geologic reservoirs in the U.S., there's just a lot of opportunity there. Some of these approaches for carbon conversion are a little bit more energy intensive, they're more expensive. So we're not saying it's going to be the majority of the pie, but that it might be a really important slice of the pie. So a lot of alternative revenue streams are also a decarbonization pathway for technologies or industries that don't have other great options or where storage maybe doesn't make sense, whether it's industry specific or even geography dependent. Just a couple notes. I wanted to highlight a few areas that we see opportunity for carbon conversion and utilization. I think a couple of the speakers will touch on these, so I won't go into too much detail, but I think in particular for our program, construction materials, fuels, and chemicals are three kind of big opportunity spaces. We do a lot of work with other offices like the Industrial Decarbonization Office that are also really focused on things like fuels and chemicals. There is also an energy Earthshot that was announced just about a year ago now, called the Clean Fuels and Products Earthshot, and I will plug that we're having an event in April. If anybody wants to join, it'll be online. But that'll be a really good survey of some of the opportunities that's going on kind of across UE, not just within FACM in regards to this space. It'll also include a bioenergy component, so probably relevant to a lot of folks in the room today. And then finally, I think I'll just wrap. We do have an existing program that I mentioned called the UpGrants program, and this is a cost share that we've developed to actually enable states and local governments to buy products that use carbon dioxide and that lower emissions as compared to an existing product. So it's a bit of kind of a new type of funding opportunity for specifically, the Department of Energy, and that it's really market development focused. We're really trying to help early movers that want to participate in this space do so. So it's a 50% cost share. The funding is open and available now, and I can maybe touch on it later in the remarks. So I won't go into too much detail, but it's an opportunity we're excited for. And I think we touched on a lot of those, so I will end there. Pass it off.
Thanks, Emily. David?
All right, so my name is David Hildebrandt. I'm a laboratory fellow at the Pacific Northwest National Laboratory up in Tri-Cities, Washington. So happy to be here. It was really great following Emily because I can basically tell you about some of the research that she's funding. So a lot of what our group is looking at doing is essentially valorizing carbon dioxide, because we do quite a bit with respect to actually capturing it. But when you start thinking about CO2 as a reagent, that's when you have to start looking at the cost of actually being able to get it. I don't think the slide ticker's moving here. Oh, there we go. So what we're looking at is, at least with respect to point source carbon capture, these things are big, they're massive, and they're going to cost hundreds of millions of dollars to build. And so what we're looking at is essentially turning these giant things into refineries of the future. So just like plants are able to absorb CO2 and make all that biomass that's making all of these fuels and chemicals that we're using today, we can essentially do the same type of thing, because all of that equipment, all of that site prep is connected to the grid, all of it's already there. So if we can do chemical conversions of CO2 while also capturing it, we think that we would be able to maybe convert 1, maybe 5% of the CO2 that we're capturing from these large point sources, and then the rest of it can go for permanent sequestration. And so in the near term, we're looking at being able to find ways to, reduce the energy demand and the cost of making CO2 neutral fuels and chemicals. In the intermediate term, we're looking at how we can actually put CO2 into building materials that would be able to sequester it, at least for up to 100 years. And then, of course, we're also looking at other ways to integrate the capture and mineralization for permanent sequestration as a way, again, to provide value throughout that life cycle. And so, as I said before, plants are already doing this. So essentially, why can't we do the same? We've already made an energy landscape argument. Actually, this was inspired by Josh Stolaroff over there, so thanks for the inspiration for the figure, Josh. But when you look at both sides of capturing and converting, it costs energy and it costs equipment, right? And so if we're going through these wild energy fluctuations to give off heat to capture the CO2, then you need to reactivate a sorbent, then you need to compress your CO2, you need to ship it. All of that is wasteful, right? So people think that you can do CO2 conversion by buying a bottle from Oxarc or what other gas supplier. That's not true. They're getting it from somewhere, and there's an energy and a capital cost associated to get that CO2 to you. And so we're looking at ways to essentially just do what plants do and take a real carbon capture medium. We've been developing technologies for point source capture, and we're actually doing catalytic transformations of the CO2 while it's in the capture medium. So again, you're doing 2 steps in one medium at the same time, and we're able to make things like methanol, methane, glycols, a whole bunch of fuels and chemicals in this. And the reason we're trying to do this is, as opposed to just making one material, we think that if you can pass the same CO2-loaded liquid over multiple conversion beds, you now have market adaptability. If your methanol market tanks, stop making methanol, start making methane. If you want to start making glycols, you can start making those. And so we think this gives you market adaptability by being able to turn on the conversion and adjust on the fly. We're also looking at the LCA and TEA. Again, as Emily pointed out, we're actually demonstrating that by doing this with renewable hydrogen, we can reduce the greenhouse gas emissions of making methanol by 72%. And by doing it together, these two steps at the same time, it actually saves us even 20% more greenhouse gas conversion emissions versus just doing those two independent steps. And so there's real tangible benefits that you can get by doing these two things at the same time. And so we're very excited about the prospects of that moving forward. For the intermediate term, we're actually looking at designing new markets that don't exist right now for CO2-derived products. Outside of cements and other areas, you know, for building materials, we want to see if we can actually get something into the average American consumer's, you know, daily lives. We're thinking of it as like putting the U in CCUS. And so we looked at decking material, which is currently made in very large amounts in the United States, like 3.5 billion linear board feet. And we just had inspiration to say, okay, rather than using wood shavings mixed with polyethylene, why can't we take large biomass polymers like lignin or even waste lignite, which, you know, is too expensive to even ship because it's so cheap. And we're looking at essentially finding ways to permanently store CO2 on that chemically. So what we found is by taking your carbon capture solvent, which is a organic base, you can essentially chemically fixate CO2 onto these large biopolymers, and now you don't have to burn them. You can store CO2 on the surface of these particles and mix them with recycled polyethylene, and we're able to make decking material with this. So I actually have some show and tell with me if anybody wants to actually see what these materials look like, but basically it's the same exact stuff that you're gonna find at Lowe's or Home Depot, and we can actually guarantee that this system will be CO2 negative as opposed to giving off 1.75 kilos of CO2 per linear board foot. Ours will actually be CO2 negative. And so we've been actually doing advanced manufacturing, sort of like when you play with Play-Doh, but we have a unique system that actually rotates and actually gives you the ability to introduce a shear, so you're processing these materials in the solid state. And we're now making, you know, 5 foot long materials that we're actually demonstrating that we can go with 80 weight percent fillers. So again, we think with about 5 weight percent CO2 captured on these particles, built into renewable or recycled polyethylene, you can store the emissions of about 54,000 cars a year just with the US decking market alone. But of course, there's furniture, there's siding, there's fencing, there's all of these other composite industries that can benefit from a similar approach. And we're very excited that our first batch of materials are actually meeting international building codes. So not only do we have something CO2 negative that can get the 45Q tax credit, but you can actually sell this as a product that would actually be able to get into the hands of consumers. And lastly, we're looking at more of what reactive carbon capture can do for mineralization. And here the concept is if you can capture your CO2 and accelerate the rate of mineralization. So here, because again, carbon capture materials are inherently basic, bases are really good at absorbing CO2, but they're also really good at digesting rock. And so you have the ability to capture and mineralize at the same time. And in a partnership with Cornell, MIT, and University of Lyon in France, we're essentially doing the capture and mineralization at the same time, but the added benefit is the chemicals that are inside the carbon capture medium are really great at pulling out trace metals. So if you still got ppm levels of nickel, cadmium, all of those rare earths that we need for batteries and other engine technologies, you're essentially able to chelate those and bring them out with you, and then we can just electroplate them, and then you just sell all of that material. So we're mining, mineralizing, and capturing CO2 all at the same time. So these are some of the earlier TRL things that we're looking at to do on behalf of the American taxpayer, and we're hopeful that these would be able to make their way into the hands of industry. And that's what I got.
Great, thanks. Hi, I'm Bill Drumheller. I'm with the Washington State Department of Commerce. Department of Commerce, we're the agency in Washington that's really focused on building communities, economic development, infrastructure, working with communities in all sorts of ways to strengthen them. And one of the key pieces of that is dealing with energy. So I'm in the energy policy section. I'm actually just started very recently, about a month ago, a new program in the energy policy section focused on emerging energy technologies. One of these emerging energy and climate technologies, of course, is carbon dioxide removal, kind of keeping with the general focus of the rest of the energy part of the Department of Commerce. I'm focused on technology-based solutions, as of course compared to some of the nature-based solutions that you all have been talking about. Just by way of background, I've been in climate policy in state government for a little over 20 years now. I'm still alive. Some of you even recognize me as a ghost from the roughly decade I spent here in Oregon at the Oregon Department of Energy, although I just most recently came from the Washington Department of Ecology. So I was asked to kind of quickly touch on some of the larger policy and sort of funding areas that in the state of Washington intersect or could potentially intersect with carbon dioxide removal. The big program we have in Washington is the Clean Energy Fund. And that, historically for the last decade has been focused more on your kind of classic renewable energy, wind, solar, and so on and so forth. One of the things I'll be doing in my new position and thinking about is how to direct these funds not only to renewable energy, clean energy purposes, but also carbon dioxide removal. So one of the ways that this is showing up just now, and our legislative session just wrapped up last week, so all this is actually quite fresh. But one of the new things as of last legislative session in Washington, and then sort of tuned up in this session, is a new reducing emissions and hard to decarbonize sectors funding program in Washington. This is a specific pot of money that is specifically focused on some of these, as we call them, the hard to decarbonize sectors, especially in Washington, aviation, maritime, and industrial purposes that have gotten a lot of discussion today. Again, this is just evolving, but keep an eye out for more news on this funding mechanism. It does specifically call out in the language the ability to talk about reducing and removing carbon dioxide from programs. Probably the biggest news out of Washington State in the last year was the relatively recent passage in the 2023 session of new tax credit benefits for sustainable aviation fuel, and and sort of the Kevin Costner model of build it and they will come. This tax credit was put in place for sustainable aviation fuel, and very shortly thereafter, Startup 12, some of you may have heard of, sustainable aviation fuel company that's focused on carbon dioxide derived sustainable aviation fuel, their E-Jet product, announced that they would be building their initial production facility in Moses Lake, Washington. That's largely because they were able to get essentially electricity, carbon dioxide, and hydrogen production all in one place. There also is a very large airfield. For those of you who don't know, it's from World War II. It's actually one of the biggest in the world. It's a massive facility. But that, thanks again to the tax credit and the decision of 12 to start up SAF production here in Washington, we now have actual, in 2024, the expectation is they'll be producing around 40,000 gallons of sustainable aviation fuel for Alaska Airlines very soon. So and I'm sure we'll touch on some of these, just some other potential policy intersections where carbon dioxide removal, we're hoping can play a place in the state of Washington policy. One, of course, is on the regulatory side. I think most people are familiar. We have our Climate Commitment Act Cap and Invest program and the Clean Fuels program that was mentioned, the Low Carbon Fuel Standard. Both of those play a role of pushing these products, but of course the funding and the revenue derived from these programs also plays an important part of creating a market for new avenues, new markets like we're just discussed for these carbon-based products. Also, another sort of hot off the press item is we just passed in Washington last session, and I should qualify that with still needs governor's signature. Chris used to work in the governor's office with me.
I'll sign it.
Yeah, but we have this new Buy Clean, Buy Fair disclosure law in Washington that is going to be very important in requiring that publicly funded building projects use environmental disclosures to essentially disclose the carbon footprints, or at least give the ability for the carbon footprints of these building projects to be determined, and build a foundation for more and future policy around building materials in Washington. And finally, I'd be remiss without pointing out the important role of our institutions. Probably should have put PNNL in there, but our state-based institutions, Washington State University, heavily involved in sustainable aviation fuels, and University of Washington particularly focused on building products and the built environment. We've also done at the state level some additional work around background studies on the potential for carbon dioxide removal in the state of Washington. Some links I think will be in the slides. So with that, I will just say that there's more to come in the state of Washington on this topic and on this panel. So with that, I'm going to turn it over to Chris Davis to talk about one of those things.
Thanks, Bill. Hello, everyone. My name is Chris Davis. I'm the Vice President of Public Policy and Carbon Products at CarbonCure. We're a climate tech company that's focused on the concrete industry. I think I'm your token non-biogenic industry rep here in today's meeting, so I'm happy to be here. As Bill mentioned, I was the Climate and Energy Policy Advisor for the governor here in Washington State for a number of years, and in between then and this, I was the International Sustainability Policy Director at Amazon. So in each of those settings, I've done a lot of work on carbon markets, from big companies and state government to NGOs to a little climate tech firm. I think I'm starting to finally figure out how the market works, but we'll figure it out from today's questions. But those will, the sort of role in the carbon market and all this will be part of some of the comments I'll make today. CarbonCure has been around since 2012. You've heard a couple references already in Emily's comments and David's to the opportunity to mineralize CO2 within the building sector and various building products. We're one of the companies that's been doing that. We have basically a licensed technology that works with concrete providers around the world to inject CO2 into the concrete mix. We've licensed it to about 800 different companies in more than 800 different systems in more than 35 countries. Company won the X Prize in 2021 for turning CO2 into a usable project. And to date, we have now avoided or reduced 400,000 metric tons of CO2 and poured about 50 million tons of concrete with some sort of reduced GWP associated with it. So the company's been around for a while doing this, which we can talk a little bit about some of the ingredients for that. Excuse me. There we go. As I said, we operate by, basically the business model is we have a very simple, it's about technology about the size of a microwave oven. You can see it there in the picture. It consists of a valve and a lot of software that injects CO2 into the concrete mix process. And that does a couple things that concrete engineers in my company, I've only been here about 4 months, drives them crazy when I use this metaphor, but in the event that you're not super familiar with the concrete sector, if you think of cake batter, that's the concrete, and the flour that goes into the cake batter is the cement. So cement is really the key input into the concrete process that creates all the greenhouse gas emissions. That's where the climate impact for concrete really lives. And by injecting CO2 into the mix, you do a couple things. You both reduce the amount of cement and therefore cut the amount of GHGs that goes into a ton. But you also mineralize, the CO2 mineralizes with the cement and actually forms a mineral. And so it's more or less permanently sequestered then within that cubic yard of concrete. A little more specifically, you've heard a little bit today from both the last panel and from David talking a little bit about the role of CO2. And just to focus in a little bit more detail how this works, our concrete producing partners, those 800 different concrete firms around the world that we mentioned, license our technology, they put it in place, and then they contract with generally merchant providers to deliver CO2 to their facilities. The CO2 gets injected into the ready mix, resulting in that cement cut that I mentioned, and then is poured out and hardened. There's a number of sort of stackable technologies that I'll talk to in a minute that we use to expand the overall climate impact of this work, but that's the key one that's sort of driven the work of the company to date. We are now, after about 10 years, in a wide range of projects, big infrastructure projects, as well as commercial projects around the world. A couple of kind of quick ingredients for success of this that maybe we'll talk a little bit more. I think the main thing that has driven CarbonCure's growth to date is the ability to create value for the concrete providers. So that cement piece that I mentioned is really one of the largest input costs if you're a concrete producer. So even at 6, 8, 10% reduction that we can provide with the technology, that's a significant reduction in costs. The other piece is you saw what the technology looks like. There's no CapEx behind this. You don't have to make a pitch to a concrete provider to overhaul what their facility looks like. We show up on a Monday morning, we bolt the machine on, it can be operating by Tuesday afternoon. The third piece is in addition to the savings from the cement cuts, that box that you saw also has a lot of software in it. We collect all the data, very highly precise, batch level, real-time data on exactly how much cement is being avoided. We translate that into data that we can then use to generate carbon credits. We take those credits to the market, and then we return half of the sales of those credits back to the producer again. So we're creating a revenue stream for them that both creates a new value basically for their operation while also introducing them to new customers who are outside of their specific value chain. And then I know today we're heavily focused on policy, so just a couple of quick points on some of the things that are happening in the policy world that I think would be helpful to technologies like this. Procurement standards like the ones that Bill just mentioned have just been recently passed in Washington State. New York and New Jersey are sort of cutting edge states who have done incentives on the tax side for procurement of low carbon energy. Part of that happens by states also doing the work to evolve performance standards for cement and concrete and other building materials to make sure that the standards themselves are less prescriptive, i.e. you must have this much ton of cement in your concrete, and more performative, i.e. it must have this compressive strength irrespective of how much cement you use. So moving towards performance standards is a big way to open up the opportunity for more innovative technologies to get their low carbon products into the supply chain. We've heard a lot today about grants and the role of the federal government in that. Emily spoke a lot about that. I won't sort of belabor it here. The last piece, I'll just reference Bill's comment about carbon programs. In addition to the opportunity to leverage carbon revenues from things like the Clean Energy Fund or from the Cap and Invest program, it's really important. I can't underscore the value and the importance of policies that increase the opportunity for companies to provide disclosure to whether it's scope 3 or across their entire emissions, especially with the recent rulings by the SEC, since we're not going to be asking companies to do this federally. Part of what you're doing when you're doing that is making visible what a company's value chain and supply chain emissions look like. That helps to create a value for it, and it creates a demand for products like ours to pull more decarbonization into the market. So handful of quick things that I think could happen in the policy front that would help us. Thanks.
Great, thank you. We're going to jump into some of these questions here, and I guess to start, maybe we'll start with you, Emily. Can you maybe talk about some of the opportunities around converting carbon conversion products and maybe some of the different market opportunities there are around the different products you can make from captured carbon?
Sure. Yeah, I think the big one that I know, as I mentioned, I think has some of the most near-term commercial applicability and opportunity, as well as the added benefit of kind of a long-lived product would be building materials. I think the ability to try to calculate or project out how long the carbon would remain in a material like for construction or buildings that, we're talking 30, 50 greater useful life is a really important part of the product portfolio when we're talking about carbon conversion, because there's some opportunities in carbon conversion like SAF it's very important, but ultimately that is combusted. And so it's not the same kind of permanent storage opportunity that something like building materials offers. But I think another place that could have a lot of opportunity is in things like the chemicals or petrochemical space, where kind of looking toward the refinery of the future, if there's a way to be thinking about carbon conversion as an opportunity to remove feedstocks that are responsible for some of the co-pollutants and some of the environmental challenges that we see from refining, also providing alternative pathways for low carbon products like fuels and chemicals. These are industries that kind of squarely fall under that hard to decarbonize sector. There are a lot of products that right now rely on fossil fuel inputs that we need alternatives for. And so, carbon utilization, I think, is very much kind of looking at what are the alternatives that we can do. And I think Dave mentioned it well, the kind of the intermediate products that allow us to branch out broadly within industry. I think, and I will say on the analysis front, trying to get some numbers that we're confident around or would stand behind for these, not only the markets for products, which I think, we can look at existing markets and kind of make take an analog and estimate, but especially around the availability of CO2 that will be available for these products is a real challenge right now, because it's tied into that sort of broader suite of carbon management, the value chain, right? So where will the carbon be? We're going to probably have to move it. So that brings in the pipeline question. And so that's kind of one of the points I had in my slide. For right now, for utilization, it's fairly place-based. We know what works well in the Gulf Coast probably won't work well in the Northeast or the Pacific Northwest. And so we're trying to determine sort of where are the best opportunities for some of these conversion technologies moving forward.
Great. So with that idea, I guess for our industry folks on the panel, Chris, how do we build up a market around some of these products? I know each one of you sort of talked about procurement and some other potential regulatory or policy mechanisms that we could potentially deploy. Could you maybe elaborate on that a little bit, on like what would be useful in that space?
Sure. Yeah, I mentioned a couple things. The role of procurement is obviously huge. The public sector builds a lot of material and a lot of buildings and a lot of infrastructure. And so for those opportunities, part of what the public sector can do is sort of help to, frankly, kind of cajole some of these lower carbon technologies in the market and help them scale. The standards piece is really big. I mentioned that earlier, but there are probably 10 to 12 states in the country right now whose Department of Transportations have done the work to sort of sort out how mineralization can work and to make sure that the building materials are sort of certified to work. The thing about the cement and concrete industry, and it's not unlike other sectors as well, it's a hard to abate sector for a reason, right? It's an old technology. It's been in place for about 3,000 years. The penalty for doing something where cement and concrete fails is high. Those two factors don't make ingredients for a really highly innovative place, and so, or highly innovative sector. So offering incentives, providing the kind of work to support certification are big factors. And the third piece is really what I said about the carbon revenue piece. None of our producers really would be working with us if the only revenue sources they were getting were expanded business and the savings from their cement cut. So the role of the carbon revenue and having a functioning liquid carbon market is a key driver, not only for our business model, but probably for many of the others that you've heard here today.
Great. So I guess on the front end side, there's a lot of research and development that has to go into sort of developing these technology pathways. So maybe David or Bill could talk about some of the research and development investment and sort of that front end cost to establishing some of these pathways.
I guess I can kind of start. Sure. So as somebody who does a lot of earlier TRL research all the way from 1 to 5, the goal primarily is to be able to show that you can get these technologies working, right? So we have to usually work with federal grants, sometimes state grants. We have to work with industry as partners to help tell us, what specifically should we be focusing on. As a chemist, when I got into carbon capture, I'm thinking, I'm gonna do this, and then the engineers are like, shh. No, that's not what we do. This is what we really need. And so I think, R&D can go in blind and can kind of, actually make things worse if you don't actually start working with those partners right up front to be able to tell you, this is exactly what we need, can you do this? And I think that's what's made us successful, at least with respect to what we've been doing for the carbon capture aspect of it, was bringing companies like Fluor Corporation and GE to come in and actually tell us how their engineering works, how we can design our chemistry to be able to work with those types of systems. So I think that's one thing that I would advocate, is that that's needed, but it's not necessarily something that's easy, right? Because industry speaks a different language. They obviously care about cost more than anything else. As a federal employee, we care about energy and the efficiency of the processes. So sometimes there's a little bit of gnashing of teeth and headbutting. But overall, I think what we've been able to do is not just hit the energy efficiency, but also the costs as well. So it's been a mutually beneficial type of R&D approach that I think that's why the national labs exist. That's essentially what we're trying to do here on behalf of industry as well as the American taxpayer.
Yeah, and I think a critical role for the state of Washington in particular, similar to a lesser degree perhaps in Oregon, but the state has some unique, specific interests, especially in aviation and maritime. I mean, aerospace is absolutely critical sector in the state of Washington, maritime similar. And so, part of the monies that when I went through my little slideshow there, part of the monies in that pot of money that I was talking about for how to decarbonize are for R&D. Washington has a strong history of work, again, with the universities, but also with, in industry sectors and industry partners within the state on, it's kind of taking some of the foundational work that national labs do and, that happens, in the universities, and really working to apply that, at the state level and specific to the, especially in maritime, some of the strong interests of seeing, things like electric ferries and, electric transportation moving around Washington. So I think, that's a a key role for the state and will be an increasingly key role for the state. I think it's already come up a couple of times. I think it's one of the key trends, at least I'm hearing and I'm seeing in this work, is there is a strong regionalization component of it. I mean, no matter how hard I try to get North Dakota to be interested in maritime, there's only going to be so much interest. And you're seeing, I think there was talk about the work in Colorado around orphan wells. I mean, there's just a very strong sort of regional interest component to all this work, and that's where I think particularly state government can really come in and hone some of its specific interests.
Great. Well, to sort of build off of that, I know each of you sort of mentioned this idea of collaborating with partners, and Emily, you talked about how utilization builds into this overarching framework for capture and transport. So maybe could you talk about how we build out some of those partnerships and how we look at where the carbon comes from and how we transport it. I know you said a lot of the stuff you're focused on is place-based, but eventually we would need to scale that to some degree. So maybe you could talk about how we would scale up utilization in some sort.
Sure. Yeah, I think one way that this is coming into some of our kind of considerations or ways that we're looking at opportunity for conversion is through some of the hub efforts that are coming out of the Department of Energy. So we have the direct air capture hubs as well as the hydrogen hubs. And I think given the kind of convening nature that those projects have had, given that they're touching along multiple pieces, the capture of the carbon dioxide, obviously, but then either the storage or the potential for use, kind of sited within a hub infrastructure or in some other sort of industrial community, I think is a really good case that we probably, we think will probably make good sense for carbon utilization in those cases. And they're also pulling together a lot of different industry partners and policymakers that have kind of a different perspective on this. And so I think those are one really valuable angle, especially when we're talking about sort of these first movers or getting these first projects off the ground. Those are kind of like a nice ready-built opportunity for us to consider. And those are also, I think, have been engaging the states really strongly and getting the state governments involved in a lot of those projects. And so for us, I think we see a lot of opportunity. They're convening also across different offices within the Department of Energy. So I would kind of lay out those probably as one ongoing example now.
Great, thanks. Chris, do you maybe have some thoughts as an industry perspective on building out some of these partnerships for utilization?
Sure. I mean, first off, I think I would just continue to emphasize that CarbonCure doesn't have a model if it doesn't have its concrete partners. And the only way that we have them is because we're bringing a value to them that didn't exist before. And so that sense of if I were back in government right now, I would be thinking, how do I make CO2 a value stream for companies? How can we do that? And pricing is a part of that. Procurement is a part of that. Making it more visible within the supply chain is a part of that. But it's absolutely sort of fundamental for us. And so that involves not just sort of fulfilling the economic prospect, but also being able to validate the performance of the technology and be transparent about those data. At the same time, we have a second major customer base, which is all the people that buy our credits, which is actually my side of the business. And so those entities themselves have their own integrity and their own transparency concerns. They want to know where the credits came from. They want to know geographically where they were located. They want to be sure that those credits weren't purchased by somebody else or double counted, or that if they're going to retire them, they're retired in a particular way that increases the integrity of the claims that those companies who buy those credits make. And so, again, sort of fundamental to that promise is transparency and clear systems that allow us to show the integrity of where these credits came from and how they're being used. So the standards that are behind both of those things, the technology standards on the concrete side and the voluntary standards that some of the other folks have referenced from this podium today, which help describe to companies what a high integrity credit looks like and what a high integrity claim that a company makes with that credit looks like, are really important sort of features and dimensions of this working and require us to be very reliant on both those customer bases, but also the NGO bodies who are writing and designing those standards.
Cool. And I'll ask one more question before we open it up for audience participation. But sort of on that customer side, could you maybe talk about some of the appetite or demand that you see from the customer side about having these lower carbon neutral products and sort of the availability at the market level? some of these products?
So we've been talking to quite a few companies, a lot in the state of Washington, that have been looking to buy some type of CO2 negative material, sort of like an Energy Star certification, that there would be something to show a green premium that they will pay to demonstrate that. So there is, sounding like there is going to be a potential market, but I don't think outside of, you know, the cement or some of the other technologies that are really ready yet. But it's good to see that industry is now starting to think about that, and they're going to start, you know, welcoming those types of products if they would start making their way to the market.
Yeah, I'll just add, I mean, not to fully contradict that, I think where I see, in cement and concrete, for instance, there isn't much of a green premium right now. There just aren't many producers, there aren't many end buyers who are speaking to a general contractor or a concrete producer and saying, I'm willing to pay X amount more per cubic yard for something that's green. It's a commodity, it's a low margin commodity. These are businesses that just simply don't have a lot of chance to pass those kinds of costs on. On the other hand, there are sectors where I think it's starting to get stronger. You're seeing more, which is why I made the comment before about the value of public policies that increase disclosure of value chain emissions, because in part led by the tech companies like the one that I used to work for, there's a lot of demand to be able to show that your full value chain emissions are going down, and that means you're focused on embodied carbon, and that means you care about what your contractors are buying. And so slowly you're beginning to see those end users pass that demand up through the value chain. That's a slow process. It's one that I'm encouraged to see where it's going, but we have a long way to go before the market is really exercising a pull for all these kinds of technologies to make them scalable and cost effective.
I mean, I would say the one area that is clearly pardon the pun, taking off is sustainable aviation fuel. I mean, for those of you who didn't see the news last week, I mentioned 12 who, you know, announced the groundbreaking at Moses Lake with their initial plan to produce 40,000 gallons of SAF a year. And just last week, they inked a deal with, I think it's International Aviation Group, a consortium of European airlines, to produce something like close to 800,000 metric tons of SAF. Just, you know, and it just one deal's leading to another. You know, for those of you who don't follow, you know, aviation as much, you know, that there's a lot of regulatory push, you know, Europe especially, but also, you know, U.S. and market push in general. So, you know, there is, I think, you know, a very much a strong push there. Maritime is perhaps not that far behind. But yeah, it is an interesting, as was pointed out, the fuel area is interesting because I think the policy focus there is probably more so on the hard to decarbonize sector, you know, approach and interests. It's obviously not a permanent solution per se, since it's being recombusted. But it's, you know, I think that it'll be interesting to see sort of both sides of this equation, you know, kind of play out over time, more the building materials and the permanent sequestration. You know, the permanent sequestration is the ideal, but certainly, you know, one of the things I didn't mention in my sort of state government checklist, but as, you know, it's come up repeatedly, and for those of us who've been around for a long time, we remember the early headaches of trying to get renewable energy, you know, wind and solar sited. Many of those headaches still remain, but now we sort of more recently added hydrogen infrastructure to that sort of checklist of, you know, permitting and regulatory hurdles. And now we're adding sort of carbon dioxide pipelines and infrastructure to that. So we seem to be adding more problems and not solving them on this infrastructure side. And so that, I think that part of it's going to be definitely very interesting. But at the same time, it's also, you know, fascinating to me. I look at on the SAF side, the, you know, potential, just kind of getting sort of a little, again, pardon the pun, blue sky here. But, you know, thinking about the possibility for, you know, land near airports, which is traditionally, you know, not had a great value, you know, often it's sort of brownfield or, you know, sites near airports, and being able to put, you know, DAC facilities or something there, and, you know, doing sustainable aviation fuel essentially on site, and, you know, recirculating that directly into aircraft. You know, things like that are pretty cool. They may not be the ultimate solution to climate, but they're certainly an interesting stopgap.
Cool. Well, I'm going to open it up for some audience questions. If we have any, just raise your hand.
Bill, you mentioned that Moses Lake has hydrogen. Where are they getting this hydrogen? Is this blue hydrogen, gray hydrogen, or is this part of something to come?
Yeah, I won't speak for 12 or their their procurement, but yeah, essentially, my understanding is it's going to be electrolytic, hydropower based electric, so blue hydrogen. They have, I assume, my understanding is they have the carbon dioxide, they have the hydrogen, and their inputs, at least for the 40,000. My guess is the European situation. I would think would be dealt with in Europe, but yeah.
Other questions?
Yeah, for Chris, at the risk of pushing you out in front of your technical headlights here a little bit, I am curious, when the CO2 is injected into the concrete, whether there is an additional, in addition to the other consequences, whether there is a weight effect. Does it, you would think when you pushed a gas into a solid that it would reduce the weight per cubic meter, for example. Now, if it mineralizes automatically, it still shouldn't add weight. So I'm just wondering whether this also has the advantage of reducing the weight without the strength of a cubic meter of concrete, which would allow different construction practices and maybe higher elevations or easier material movements or anything like that.
Great question, I guess. To my knowledge, it does not affect, we're talking about on the margin, right? So we're not talking about a big weight difference. Other attributes that it does affect, here's the extent of my cement and concrete technical knowledge and technical vocabulary, is slump and spread. And so part of what you care about if you pour concrete is how long from when you empty it out of the truck it's going to take to sort of fill the form or to fill the tower, and how long it's going to take to cure down into a position where you can remove everything. And so those are features that lead to different choices about cement mix, which then lead to different choices about what cement goes where. The cement that you pour into a bridge on-ramp is not the same cement and concrete that you pour on your patio on the back. And so that compressive strength and that ability to have structural and integrity governs how much CO2 you can inject into the mix. And so we need to know, what do you plan to use the concrete for? Part of what that technology box does is then modulate how much CO2 you can inject based on what kind of cement there is and what it's going to be doing. So at the end of the day, I think the answer to your question is no, there isn't a big change in the weight, but there are big changes in other performance attributes of the concrete depending on how and how much of the CO2 you inject in.
Any last call for questions? Yeah.
Thanks. So David, Bill, and Chris, each of you talked about potentially the use of decarbonized or lower carbonized materials for building products. Do you see that one of the things that might be able to drive greater adoption of this is stuff like the California Building Code change about 10% decarbonized on embodied carbon in buildings? New York is doing a similar thing.
Yeah, a lot. I mean, I think this is too big of an issue to unpack at this point in time, but I'll just plant the seed. I mean, one of the reasons, not the only one, but one of the reasons why Bill could reference SAF and talk about why SAF is doing better than some of these other sectors, for those of you who, somebody else in the last panel referenced the obscure and arcane world of GHG accounting. But SAF has what's called a book and claim system, which means if you're a buyer and you want to buy the right thing, you want to buy your sustainable aviation fuel, but all your flights are between Madrid and Paris, and all the SAF is in Dresden. The only way that you can do that is if you can buy the attribute of the fuel in Dresden and apply it to your fuel that's flying between Paris and basically what I'm describing is what we've been doing in renewable energy with REX for 20 years. But increasingly, you're seeing that kind of system emerge for sustainable aviation fuel. There's an initiative to do it for maritime. There's an initiative to do it within cement and concrete. What that will allow is that if you pass a law like that in New York, and suddenly all the concrete producers have to comply with it, but there are no carbon cures or there are no other solutions to do it, how do you solve it? You find a producer that does have it, you purchase the attribute separate from the physical commodity, and you apply that attribute through your accounting to your own footprint. That combination of a procurement standard with a flexible accounting mechanism is a golden combination to increase proliferation of these technologies across sectors.
Yeah, and I think just, you know, the kind of a follow-up on the recently passed by clean by fair law in Washington. Again, the law itself is not a procurement standard, it's a disclosure standard, but it, you know, maybe a little charge, but it doesn't take a rocket scientist to figure out that by requiring that disclosure, it would allow cities, counties, local governments, you know, all levels of government who do have and whose citizens do have an interest in, you know, putting in place those kind of standards, that it provides the data foundation to do that. So that's, you know, it really is, it's a critical first step to that possibility.
And just a quick note on that, there is also a federal buy clean standard as well. So the federal government is really trying to think about the vast amount of materials that they procure, and how we can start to build in some of those standards, kind of starting first and foremost with the things that we're building, you know, on site or our own construction projects and things. So, you know, that's a lot of money to move in some of these industries. So I think, you know, getting that off the ground could also be valuable, because that could also spur more movement, particularly in the standards space, around things like performance-based standards, which we know is, you know, we hear that all the time, that's like such a critical, a critical gating area. So for anybody that might have a role in that. But yeah, so that's just to flag that opportunity as well.
Great. Well, thank you, Emily, Dave, Bill, Chris. Thanks for being here. Please join me in thanking our panelists. We're going to take a short 10-minute break before we wrap things up roundtable for the day.